In the last lesson, we said that whenever an object is at rest, that's to say it's stationary or not moving, then the forces acting on it must be balanced. Now here we can see 4 balls. In fact, we've got a football, 2 cannonballs and a ping pong ball, and all of these are at rest, they're motionless. And in each case, a force is acting downwards on them, produced by the force of gravity. In this case, and the name of this force is the weight. Okay, so we've got weight acting down on the football, on the cannonball here, which is positioned on top of a trampoline, and another cannonball here which is positioned on top of a table, a hard oak table, and another. We also have the weight here acting down on this ping pong ball, which is floating on top of a jar of water. Okay, so in order for these objects to be motionless, there must be some other force acting in the opposite direction to balance the weight. Now, in the case of the football, that force is produced by my arm pushing upwards. Okay, and that exactly balances the weight of the ball, so the ball doesn't move. Now, in the case of the trampoline, what happens is the ball, the cannonball, which is a heavy object which is placed on top of the trampoline, will deform the trampoline, which is elastic. It will stretch the trampoline until the force produced by the trampoline exactly balances the force produced, the elastic force produced by the stretched trampoline exactly balances the weight of the ball. So in this case we have what we call the elastic force. Now, what about the case of the cannonball on the hard oak table? That's a thick oak table there, and you might say, well, what's pushing back on the ball here? Well, in fact, the tabletop does exactly the same thing as the rubber sheet on the trampoline. It deforms, it bends slightly, and that produces an elastic force which balances the weight. So we've got an elastic force again here. Now, the only difference between this situation and that of the trampoline is that you can't really see, it's very difficult to see the deformation of the tabletop because it only deforms by a small amount. Whereas the rubber sheet on the trampoline is designed to stretch easily when it produces the elastic force. Okay, so let's put again the elastic force here. Now, what about in the case of the ping pong ball that's floating on top of the water? Well, we've got the weight acting downwards, but something must be pushing the ping pong ball in this direction, the opposite direction, otherwise it would sink. Now, the name we give to this force is the upthrust. Now, depending on where you are in the world, you may find that there are other names given for this force. For example, the buoyant force is quite common in many countries. All right, I'll write that beside it, the buoyant force. To summarise, whenever a body is at rest, motionless, then there are always forces acting on that body, always. But what we can say about those forces is that the forces are balanced. Now, in the context of these diagrams, that means that the forces are equal, that's the same, they're the same size, but they're acting in opposite directions. And as a result, they cancel each other out. So, balanced forces are equal but opposite. That's to say, they're the same size but act in opposite directions. And so cancel each other out.